Okay, so this video is going to work through the questions about this Boston Globe scenario. It's questions 17 to 24. And this year we're looking at data that the Boston Globe collected regarding a random sample of traffic citations issued for speeding by the Boston Police Department between April 2001 and January 2003. For each of the citations, the race of the person cited and the type of citation were recorded, and the results are tabulated here. So we can see that among minority drivers, there were 1,485 who received warnings, 1,945 who received tickets. Among white drivers, there were 1,525 who received warnings and 1,335 who received tickets. So the first question is, what are the cases in this study? And this is something you have to think about very carefully in this situation. Remember that the cases are the units that they collected the information about. And so when you're trying to distinguish, is it the drivers or is it the citations, right? You have to ask yourself, what was it a sample of? They collected a data for each citation they recorded information. So it's really the citations that are the sample. And in fact, it's possible that the same driver may have been cited more than once in this sample. So we need to be careful to kind of think about that. When we're thinking about what type of study design was used to collect the data, we've got a situation here where we have an observational study. And it's observational study because, remember, to be an experiment, the explanatory variable, which here is whether the person is a white driver or a minority driver, would have to be randomly assigned or controlled by the researcher at least to be an experiment. And this is a situation where it's something that can't be assigned by the researcher. So clearly it has to be observational. Question 19 says, if the results show that minority drivers are significantly less likely to receive a warning than white drivers, can we conclude on the basis of this data that race causes a driver to be less likely to get off with a warning? Now remember, when we're trying to make a cause and effect conclusion, we need to know that there was an experiment with random assignment. And in this case, because it's an observational study, we can't make a cause and effect conclusion. So here the correct answer is no, the explanatory variable was not randomly assigned. And that's what we would need in order to make a cause and effect conclusion. Question 20, we're going to conduct a hypothesis test at the 5% level of significance to test for an association between race and the likelihood that a driver will get off with a warning. So we want to know what will be the null and alternative hypotheses. So in words, we're testing to see if there's an association between race and whether a person gets a warning. So that's our alternative, that there is an association. Our null hypothesis is that there is no association. Between race and whether a driver is given a warning. So we're given a randomization distribution here that was simulated in StatKey using 1,000 samples. Remember that the purpose of the randomization distribution is to show us the types of differences that might occur due to random chance if the null hypothesis is true. And so question 1 asks why the randomization distribution is centered close to 0. And the reason that it's centered there is because the null hypothesis is that there's no difference in the chance of getting a warning between minority drivers and white drivers who are cited. The whole purpose is to see what kinds of things would be consistent with results that might have happened by chance if the null hypothesis were true. So the randomization distribution is always centered around the null hypothesis. Question 22 asks, based on the simulated randomization distribution, what is the p-value? Remember that the p-value is the chance of seeing our observed sample statistic, and here that's a difference in proportions of negative 0.10, or something more extreme if the null hypothesis is true. So I'm looking at this distribution of results, simulated assuming the null hypothesis is true, and I'm looking for this sample statistic. But it's way down here somewhere. So the proportion of dots down in this tail is 0 out of 1,000 samples resulted in something that extreme. So my p-value based on the randomization distribution would be 0. Now I was testing at the 5% level of significance. So since this p-value is less than 5%, I'd be rejecting the null hypothesis, which means that there's strong evidence in favor of the alternative, that there is an association between race and whether a person gets a warning. And so the next thing I want to do is look and see what that association is. Now keep in mind, group 1 here are the minority drivers. And we're looking at the proportion who will get a warning, and we can see that that's lower in the minority drivers. So when I'm making my conclusion, even though it was a two-tailed type of test for is there an association, what I can conclude is there's strong evidence that minority drivers are less likely than white drivers to get a warning. And then the last question in this set asks, which of the formula-based hypothesis tests listed below would have been appropriate to use in this for this test? So because we had two categorical variables, right? We had race, which was classified as minority or white, so into two categories. And we had ticket or citation, so that's another variable with sort of ticket or warning, sorry, which is the type of citation, which also has two categories. We actually have a choice here. We could use a chi-square test for association, because that will work anytime I'm looking for an association between two categorical variables. But in this case, I could also use a z-test for a difference in proportions, because I've only got two categories for each one. So either one of those tests will work. A t-test won't work at all because we don't have a quantitative variable to calculate a mean for. And a chi-square goodness of fit test won't work because that only works for situations where we've got one categorical variable. And in this case we have two, so that one is not going to work. So the correct answer here actually is E, that both A and B would be appropriate. Okay, we'll stop there and we'll do another video picking up at question 25.